we're going to continue with partial fractions this week, focusing on, I think, what is section 1.5, which we're just going to refer to as improper fractions. So you'll remember that when you were younger, you probably looked at things like 14 over 3. And you would have been happy with the fact that that was what we called an improper fraction, and you'd be happy with the fact that we could write that as a whole number of 3's, and then however many 3's were left over, or however many thirds you would need. So 4 times 3 is 12, so I'd have 2/3 left over. That is what we're going to be doing now. So we're going to be taking an improper algebraic fraction. We're going to be working out kind of how many times the bottom goes into the top, and then with the remainder we're going to be splitting that into partial fractions. Now this is a skill that we really, really need later on, because it's a skill that allows us to be able to integrate things that we otherwise wouldn't be able to integrate. So it's really important. I think probably the first thing to say is that in algebraic fractions, so an algebraic improper fraction, because it's quite hard to say if the top's bigger than the bottom, because we've just got x's and stuff. The order of the numerator has to be greater than or equal to the order of the denominator, or we can say the degree. That just means the highest power. So if the top was an x cubed expression and the bottom was an x squared, the top is bigger than the bottom. That is an improper fraction. So let's say the degree of the numerator is greater than or equal to the degree of the denominator. So I'll give you some examples now of what we mean by that. So the degree of the numerator is greater than or equal to the degree of the denominator. For example, x cubed plus 4 over 2x squared minus x plus 3. That would be an improper fraction. But equally, x plus 4 over x plus 1. That would also be an improper fraction. The degree of the top is 1, and the degree of the bottom is 1. So the degree of the top is greater than or equal to the degree of the bottom. So it just means that the power of the top is either the same as or bigger than the power of the bottom. And that's really, really important. It's going to mean that we can write fractions as a number and then plus some other fraction, which we'll then be able to use partial fractions of. So let's have a look at, I'm going to try and keep my book straight. I've got a habit of rotating it. I'm going to try and keep it straight. Let's have a look at x squared plus 3x minus 2 over x minus 1, x minus 2. So your first decision now is that an improper fraction? Well, let's just have a look at what I would get if I expanded the bottom. We're going to have to do that anyway in order to be able to do our division. So x squared, then I've got minus 2x minus 1x, and then I've got minus 1 times minus 2. So in fact, they're really, really similar, but the degree of the top is the same as the degree of the bottom. Hence, I do have an improper fraction. Hence, I do need to do some kind of division in order to work out this number. How many times does the bottom go into the top? So we've done polynomial division. Some of you really liked it. Some of you didn't. So I'm doing x squared plus 3x minus 2, and I'm dividing it by x squared minus 3x plus 2. So I'm dividing this by this. So I look at this first term. How many x squareds go into x squared? Well, that's 1. So I've got an x squared, and then I've got a minus 3x times 1, and I've got a 2 times 1. Right, now we take them away. This first term should cancel. That's how we've set this up. So x squared take away x squared goes. Then I've got a 3x minus a minus 3x. which gives me 6x, and I've got a minus 2, so minus 4. Your next question would be how many x squareds go into 6x? But we can't do that. So we stop here. This is as far as we need to go. So this fraction that we started with, x minus 1, x minus 2, that equals 1 plus the remainder over what you were dividing by. Which is exactly what we do, isn't it? That's how many times it went in, and then we could put a plus in there, what was left over and what we were dividing by. So nothing is changing, we're still just doing normal division. Right, now, I don't know why I didn't write that bottom in factorised form, because we're going to need it factorised, because now we're going to partial fraction this bit here. Because at the minute we're still not in a form that is easily integratable. So we're going to now partial fraction this bit. So I'm going to say that this equals 1 plus, well, I'm going to have a over x minus 1 and b over x minus 2. Now I did a little mental check there to check that I didn't have a repeated root. They could be nasty like that, but I haven't got a repeated root, so I just continue now. So, what you might want to do now is ignore everything else, and we're just going to continue with this part here. Because the 1 is going to be there, I just need to work out this bit. So I think, in fact, I'm going to go up here, and I'm going to say that I need 6x minus 4 over those brackets to equal a over x minus 1 plus b over x minus 2. So remember, you try and make the bottoms the same. So I need to multiply the top and bottom of this one by x minus 2. And that's going to give me the same bottom. And I multiply the top and bottom of this one by x minus 1. And that's going to give me the same bottom. Now the bottoms are the same. When I add them, I just add the numerators. And the bottom stays the same. Once you're in a position whereby the bottoms are the same, then you can equate the tops. So at the minute, I've got 6x minus 4 over this thing equals an a something plus a b something over this thing. So we're at the point now that we can say that the numerators must be equivalent. So now I say that 6x minus 4 equals a x minus 2 plus b x minus 1. So now again, you've got a choice of methods. You can stick in numbers or you can equate coefficients. It doesn't matter which one you do at all. I'll do both. I'll equate coefficients first. So let's equate the x coefficient. So on this side I've got 6, and on this side I've got an ax and a bx. And let's just equate the numbers. Well, on this side I've got a minus 4, and on this side I've got minus 2a minus b. Right, well, I can add these two equations, look, and my b's will go. So I'm going to add these equations, and my b's are going to go. So 6 add minus 4 is 2. A plus minus 2a is minus a. And b plus minus b goes. So I get that minus 2 equals a. And then I need to stick that in. So 6 equals minus 2 plus b. So b equals 8. Now I'm going to do it the other way and hopefully get the same thing. So what am I going to do? Let's sub in 2 so that this bracket becomes 0. So on this side, what do I get? 12, 8. Yeah, because 6 times 2 is 12, take away 4, which is 8. That bracket's going to go because when I stick in 2, that's going to be 0. And when I stick in 2 here, I'm just going to get 2 minus 1, which is 1. So I'm just going to get that 8 equals b. And then I'm going to sub in 1. So on this side, I get 6 minus 4, which is 2. And on this side, I'm going to get 1 minus 2, which is minus 1. So I did, in fact, get the same thing. Rather fortunate. Right, so what's my final answer then? It's 1 minus 2 over x minus 1 plus 8 over x minus 2. I just subbed in my a and b into this expression here. So the only thing that's changed now is you have to do a little bit of division in order to find that initial number. It could be an expression. So if I had an x to the 4 on the top and only an x squared on the bottom, you might find that rather than just having a number here, you have an algebraic expression. So you might have an x plus 1 or something like that. It will probably tell you in the question whether you're looking for an expression or whether you're looking for just a number. Okay, yeah, for example, if you look at question 10 from 1g, that wants you to write it as ax squared plus bx plus c, because the degree of the top is 4 and the degree of the bottom is 2. So you're going to have to multiply the bottom by an x squared term to get the same as the top. So you would do that, you would do your division. Once you've done your division, you then get left with something like we did here that you could then try and do partial fractions with. I asked you to do a sheet last week for polynomial division. 1F is just looking at division. So 1F is practicing polynomial division. I'll do one of them now just to refresh your memory. And then 1G is this concept of having a term kind of out the front and then the partial fractions. So this takes us quite nicely up to the end of chapter 1, and it also quite nicely gives you half term in order to finish chapter 1. So I'm going to move on after half term. Half term is next week. I'm going to move on after half term onto the next topic. So please attempt to finish mixed exercise 1. I'm just going to do question 1 from 1F now to just in case you're struggling with the division. So I'm going to do question 1 from 1F, which is x cubed plus 2x squared plus 3x minus 4 over x plus 1. And it wants you to write it in the form ax squared plus bx plus c plus d over x plus 1. All this is asking us to do is do a division. We want to divide that numerator by the denominator, and then we're going to write our answer like this. Okay, so let's have a look. So I need to do a division. So I'm dividing this. Oh, I've rotated my book again, and that doesn't look like it cubed. I'm dividing this by that. So I'm going to say how many x's go into x cubed? Well, that's x squared. So I do x times x squared, which is x cubed, and 1 times x squared, which is just x squared. And then I'm going to take them away. So I've got x cubed minus x cubed, which goes. 2x squared minus x squared just gives me x squared. And then I bring down the bits I haven't dealt with yet. Right, how many x's go into x squared? Well, that's just x. So I've got x times x, which is x squared. X times 1, which is 1, x. Then I'm doing x squared take away x squared, which goes. 3x take away 1x, which is 2x. And then I bring down what I haven't used. And then for this last bit, I say how many x's are in 2x. So I've got x times 2 and 1 times 2. And then I've got 2x take away 2x, which goes. Minus 4 minus 2, which is minus 6. So my answer then will be x squared plus x plus 2 minus 6 over x plus 1. Okay? So that was question 1 from 1F. We did polynomial division last year, so 1F practices that, and then 1G combines it with partial fractions. It isn't any more difficult, it's just a little bit different. It kind of combines 2 skills together. So remember to get in touch if you'd like the details of the Zoom help session, which this week is going to be on Friday. Both me and Mr. Barker are in school on Thursday, so that's going to be Friday at 9 a.m. If you'd like to come, just let me know and I will send you the details. Other than that, I hope you're well. There won't be a video next week because it's half term. So your holiday homework, as it were, will be to have a good go at mixed exercise 1. Any problems, of course, you could bring to the help session after half term. I hope you're all well, and I look forward to seeing you as soon as I can. Bye.